Hello guys, welcome to Contest Video Solutions by Smart Interviews. Today we are going to discuss the solutions of Starters 142. So yeah, let's get started. In a football match, a penalty shootout is used to determine the winner if the score is tied after regulation and extra time. Each team takes turns attempting 5 penalty kicks. Team A has scored X goals in 3 turns and Team B has scored Y goals in 4 turns. So there are two teams, A and B. Each team will have 5 penalty kicks, out of which A has used 3 turns and scored X goals, and B has used 4 turns and scored Y goals. Next, determine if it's possible for the penalty shootout to end with equal score after both teams have taken all 5 of the penalty kicks. So A can take 2 more kicks and B can take 1 more kick. We have to figure out if, let's say, Z1 and Z2 are the final scores. We have to figure out if Z1 equals to Z2 or not. If there is a possibility for that or not. Input format. The first line of input contains single integer t, denoting the number of test cases. Each test case contains two space separated integers x and y, where x is number of goals scored by team A in their 3 turns, and y is number of goals scored by team B in their 4 turns. Next, output format. For each test case, we simply have to print yes if Z1 can be equal to Z2 and no if there's no possibility of that. And it's clearly given. The output must be separated by a new line. And the standard thing, yes can be printed in any way and no can also be printed in any way. That is, each alphabet can be in any case, lowercase or uppercase. Next, there are t test cases. X will be less than or equal to 3, of course, because there are only 3 turns used by team A, and Y will be less than or equals to 4, because team B has only used 4 turns. Next, sample area is given. So first input is 1 and 2. Team A is 1 and team B is 2. That's close. Now, there are 2 more chances for team A and just 1 more chance for team B. Team A, if it is scoring in the second chance, so the score will become 2. And if it's scoring in the third chance as well, I mean, in the remaining 2 chances, the score will become 3. So already 3 chances were used and score was only 1. In the fourth chance, if the score will become 2. And in the fifth chance, if the score will become 3. Coming to team B, 2 is the current score after 4 turns. Now if they are scoring the last goal, the score would become perfect. 3. So we simply have to check if there is a possibility of one number from here to be equal to one number from here. If we say there are two such cases, so the output is yes. Coming to the next sample here, team A has scored 3 goals and team B has scored 0 goals. So 2 more chances and just 1 more chance. These 4 possibilities are 4 and 5, and here it could go to 1. Do you see any number from here to be equal to any number from here? No. So there's no possibility of them being equal. So it's a no. They ask us 1 and 1. They're already tied. So if the next 2 chances are not scoring anything, it would be a draw. So that's a possibility for draw. I hope this sample is clear. Now coming to the approach, team A has scored X goals and team B has scored Y goals. So in their fourth turn, if they are scoring a goal, team A score would become X plus 1. And in their fifth turn as well, if they are scoring a goal, the score would become X plus 2. Correct? Similarly for team B, they only have 1 more chance. So if they score, the score would become Y plus 1. For the possibility of draw, any number from here should be any one number from here. That is, x should be equal to y or x should be equals to y plus 1. So we got two cases. If x equals to y or x equals to y plus 1, in both these cases, there is a possibility of draw. Similarly, x plus 1 can be equals to y or x plus 1 can be equals to y plus 1. So that brings us to the third case. X plus 1 equals to y or x plus 1 equals to y plus 1. So if you are taking x plus 1 equals to y plus 1, this is nothing but x equals to y, which is already considered. So I'll skip that case. Next, x plus 2 equals to y or x plus 2 equals to y plus 1. That's x plus 2 equals to y and x plus 2 equals to y plus 1. If we subtract 1 on both sides, we get x plus 1 equals to y, which is already taken. So checking these four cases would be sufficient. So if x and y are the given inputs, if one of these cases is true, then we can simply return yes or print yes. Else we will be printing no. Shall we code it up? Okay, let's code it up. First, let us take the input int, cint, and loop t times. Each time two space separated integers are given, we read them as well. And if there is a function which will say if the result can be drawn or not, we'll simply call it and the output should be separated by a new line. So what should result of function return? Directly yes or no. So return type would be string. Now if one of those four cases is true, we return yes. What are the four cases? If x equals to y or x equals to y plus 1 or x plus 1 equals to y, and the last case is x plus 2 equals to y. If one of these cases is true, we simply return yes. Else we simply return no. That's it. Shall we test it? The expected output is yes, no, yes. Perfect. Let us submit and check. Done. That's it. Let us move to the next question. Second question. Chef loves pizza. Chef loves halves. Flower by chef. So the chef has a unique way of cutting round pizzas. He starts by cutting the pizza in half, then in quarters, then in eighths, and so on. Always cutting through the center. Below is an example of cuts made by chef in sequential order. So one cut is dividing the pizza into two halves. Then the next cut, four quarters. Then one more cut. We got six sectors. Then one more cut. We got eight sectors. Then one more cut. How many sectors did we get here? It will be 10. Done. So from this, what do you understand? For each cut, the number of slices is increasing by 2. What else is given? Chef wants to cut pizza into X slices, where X is always even. So here it's given slices. So in this case, the cut will be made like this, then one slice will be added. But if the whole cut is made, then two slices will be added. But it's clearly said X slices, where x is always even. So a small twist in the question. Here, this whole thing is not considered as one cut, but two cuts. That's the only thing different. Next, your task is to determine the number of pieces that will be smaller than the rest. So, input format, the first line will contain t number of test cases, and each test case will simply contain x, that is the number of slices chef wants, and x will be an even integer. Output, the number of slices which are smaller than the other. T will be 10 power 5, x will be 10 power 5, and x will be even as well. So, 2, if you are making 1 and then 2 cuts, how many slices are smaller than the other? 0 because all are equal. Then 14. So, here it's clearly given 14 cuts is displayed in picture 7. Where is picture 7? Over here. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 slices which are smaller compared to the other slices which are bigger. Now, how can we get the answer? We know one cut will give us two slices. So every time, if I'm making one cut, I get two slices. And if I'm getting one more cut, I get four slices. That's one observation. What's the other observation? In which cases, or when x is what value, we will get equal sized slices. So first, when I make one cut, I got two slices. How many cuts should I make such that we get equal slices? Two more cuts. Then we get equal slices. Now if I'm further cutting the slices, how many cuts should I make? Four more cuts. Then after that, we got eight slices. And if I'm making one slice into two, then we get two smaller slices. But if I want to make them equal, each of this must be cut in the same way. So into two. Again, if I'm moving further, number of slices will be into two of this and then into two. So what did you observe from this? If the number of cuts made is a power of two, then we get equal slices. And after that, for each cut, what will happen? We will get smaller slices. So, so if x is given, how can we get the answer? We want the nearest power of 2 of x. Let us call that as y. Then, for each cut made from y to x, that is x minus y cuts, we get a new slice every time. How many slices we get for each cut? Two new slices. So can I simply say x minus y into 2 will be the number of slices which are smaller? That's it, right? So what's the main task in this? Finding this y. If a number x is given, let us take 9. We want the nearest power of 2 to 9, which is lesser than or equals to 9. It will be 8. But how can I get this? Should I start iterating? Of course, that will take a lot of time. If we iterate, let us say you are given some random number and you have to start iterating. So until you get the power of 2, you will keep on iterating. which is not at all suggestible. Our complexity will be very higher if we do this. So what else can we do? Perfect, guys. Those who said we can simply get the last set bit from the given number. You're right. Perfect. Those who couldn't get it, from this, if you want the power of 2 which is lesser than or equals to the given number, nearest one, I'll simply make all the bits to 0 except the MSB bit. Then that will give me the power of 2. So I hope the approach is clear. Let us. The first line of input contains the number of test cases, and for each test case, an integer x is given. And what are we supposed to do? Find the nearest power of 2 for x. Once you get this, what are we supposed to do? We print the answer as x minus y into 2, separated by new line. So if you fill this function, it's done. Now, how to get the nearest power of x, which is less than or equal to x? Simple. If we get the number of bits in x, we can simply return 2 power number of bits minus 1. How to get the number of bits? Let's count them. Int cs and 0. So while x is greater than 0, it will have some bits in it. So how can we move bit by bit until the number becomes 0? Simply do right shift x assigns x right shift 1 and every time increase the count. And what are we supposed to return is nothing but 2 power x. In this case, the count of set bits we want, so count is c, and 2 power c minus 1 should be written, so we simply return 1 left shift c minus 1. Let us run it and check. We got 0, 12, and 6, 8, 9 to 8, and the expected output is also that as well. Let us submit and check. Perfect. Now let us move to the next question. Array removal. You are given an array A of size n. Your task is to determine the minimum number of elements that need to be removed from the array A such that bitwise OR of the remaining elements is 2 power x minus 1. So what's the information we got from this? We are given an array of size n and we are supposed to check the count of minimum elements to be removed such that the bitwise OR of remaining elements will be 2 power x minus 1. Note that the bitwise OR of an empty array is considered to be 0. If no element is there, the output will be considered as 0. That means if there is no way to get 2 power x minus 1, we can simply remove all the elements, which will result in 0. And we know 0 can be expressed as 2 power x minus 1. So 2 power x equals to 2 power 0 when 1 is equal to 2 power 0. So x is equal to 0. So if there are no elements, then we can simply take 0 elements and it's clearly given x can be greater than or equals to 0. Now moving to the next part of the question. Input format. The first line of input contains t, that is a number of test cases. The next line contains n and then n number of integers that are integers of the array. So first t, And for each test case, n and the array elements are given. Then next the output format. We simply have to print the minimum number of elements that need to be removed from the array. Constraints: t is up to 10 power 5, n is up to 10 power 5, and array elements can be anything from 0 to 10 power 9. The sum of n overall test cases won't exceed 3 into 10 power 5. So the significance of this is t is equals to 10 power 5, n is equals to 10 power 5, and t into n is 10 power 10. But we know at most we can do 10 power 8 iterations, but here itself we are getting 10 power 10. So that is why it's clearly mentioned the overall test cases won't exceed 3 into 10 power 5. So which is less than 10 power 8. Clear? Let us check the sample input and output. Two test cases are given. The first test case is containing two integers, which is 6, and the other integer is 16. 6 can be represented as perfect 0 0 double 1 0. 16 can be represented as 1 0 0 0 0. So this is 2 power 0, this is 2 power 1, 2 square, 2 cube, and 2 power 4. 16 is 2 power 4, and 6 is 4 plus 2, so 2 square plus 2 power 1. If we do OR of this both, what do we get? 1 0 1 1 0. And if we just take 6, that is not 2 power x minus 1. If we take 16, even that is not 2 power x minus 1. And how am I able to directly say if it's 2 power x minus 1? If this can be expressed as 2 power x minus 1 or not, and if this can be expressed as 2 power x minus 1 or not. How am I directly saying it? Okay, look at this. 2 power x minus 1. The significance of this is, if you are taking 2 power x, what are the possible things? You can take 1, you can take 2, which can be represented as 1 0. Then the next power would be 4, which is 1 0 0. Then the next power would be 8, which is 1 triple 0, and so on. Yes, this is 2 power x. What is 2 power x minus 1? In this case, it is simply 0. In this case, it is 1. In this case, it is 3, 4 minus 1, which is 1, 1. In this case, 8 minus 1 is 7, which is triple 1. And in this case, 16 minus 1 is 15, which is 4 ones. So I have now we understood what's the significance of 2 power x minus 1. It will contain all ones only in the binary representation. So how? If you take any number consisting only 1 1, then all zeros. And if you subtract a 1 from it, you will get all ones, and this 1 would turn to 0. So that is why we simply get all ones. So that's the significance of 2 power x minus 1. And that is how I directly said this cannot be expressed as 2 power x minus 1, and this cannot be expressed as 2 power x minus 1. So the first thing we figured out is 2 power x minus 1 contains only ones in the binary representation. Now, 6 section we have already checked. Coming to 1, 17, 18, 5 and 6. 1 is simply 0, 0, 0, 0, 1. 17 is simply 16 plus 1. 18 is simply 16 plus 2. 5 is simply 4 plus 1, and finally 6 is simply 4 plus 2. These are the binary representation. If you do OR of everything, we are getting 1 0, 1 1 1. So we have to figure out if there is a way to only get 2 power x minus 1. And we clearly know this is not 2 power x minus 1 because it contains a 0, not only ones. Now moving to the next part. The output given is 2. That means by removing two elements, we are able to get 2 power x minus 1. If we clearly observe, there is no way of getting 1 in this position because any number you take, it does not have 1. So OR would never result in 1. So considering these two is of no use. So we'll take 1, 5 and 6. So considering only 5 and 6, which is 101 and 110. And if we do OR, we are getting 111, which is equal to 7. So we can remove all these three, 1, 7, 17 and 18. But the question clearly said, minimum number of elements that needs to be removed. If we put 1 with this, the OR would still be 7. So 1 can still be included. It need not be removed. So we only remove 17 and 18. That's how we got the output as 2. Everything's clear so far. So the second point is remove minimum number of elements. Now if all this is clear, we have to figure out how to solve this. If you have any approaches, before I reveal it, comment your approach in the comment section. And yeah, here we go. So first thing, 1 binary representation is simply 1. 2, it's 1 0. 3, it's 1 1 0 1. Sorry, 1 0 0. 5, it's 1 0 1. 6, it's 1 1 0. 7 would be 1 1 1. Then for 8, what would happen? Now we got only 3 bits, right? We'll be getting one more bit. 1 triple 0. So the possible 2 power x minus 1 values are 1. Of course, 0 is also there. But for now, let us not consider it. Then 3, then 7, then 15, then 31, and so on. So for us to get 1, can we consider this? Of course, no, because this bit is set in 2 and 3. So if you consider those, you can never get 1. And for 3, can you consider 4, 5, 6, and 7? No, because this bit will be set when we do OR. So we can only consider anything in this. So for 7, we can consider anything from this. And similarly for 15, from which value to which value can you consider? Perfect. Any value below 16. So we understood to check first if 1 is possible, then 3 is possible, 7 is possible. Our elements cannot be greater than those. So it cannot be from 4 for 3. It cannot be from 8 for 7 and so on. So that's one more point to observe. Next thing, let us say we have 0 1 and we have 1 0 0 and then we have 1 0 0 0. If we do OR, what do we get? Double 1 0 1. Why did we get this? Because 2 and 3 are not present, which contribute for this bit. So we cannot directly do OR for 1 and 4 and directly say 7 is not possible. Yes. So while doing OR, we need to follow the other. So 1 must be ORed with 2 or 3 before doing with 4, 5, 6 or 7. So once we are sure 3 is not at all possible, then we can check for 7. So 0, 1, 1, 0, 1. 2, 3 is not there. So we are directly saying 3 is not possible. Of course. Now, if we have a 6, in this case, 7 is possible now. So our next observation is while doing OR, we have to go in an order. We cannot skip the order because if we are skipping the order, we will never know if these numbers are possible or not. So in this example, we took 1, 4, 8. Let us say after this we have a 2. Considering only this, we are saying 3 is not possible. But if we considered 1 and 2, getting 3 is possible, which is 2 power x minus 1. So first, we need to sort our data 1 to 4 and 8 and only then continue doing OR. Correct? Perfect. So that is another observation. That is, we need to sort the data. Only then we can check integer by integer. Are you able to think of an approach before I reveal the final step? If yes, just comment down yes. Fine. Those who couldn't figure it out. So for this case, 1, 17, 18, 5, 6. It's simply 0, 0, 0, 0 and 1. This is simply 1, 0, 0, 0 and 1. This is 1, 0, 0, 1, 0. This is 0, 0, 1, 0, 1. And for 6 it is 0, 0, 1, 1, 0. In this case, 7 was the answer. So if we did 1 or 17, we'll get the answer as 1, 0, 0, 0, 1. Correct? That is 17 itself. From this, is there a possibility of getting 7 after doing OR? No, because this bit became set. We cannot unset it by doing OR. So, that was the observation we just made. Our data should be sorted. Now the data is sorted. Now let us start doing OR. Here we got 1. So now we know that 1 is 2 power x minus 1. Is it correct? So for x equals to 1, we know that we can get 2 power x minus 1. And one more way, as we discussed, it has only 1. We know if the bit representation is containing only ones, then yes. So yes. Now when we do OR with 5, what do we get? 101 itself. 1 OR with 101, we get 101 itself. Correct? Is 101 2 power x minus 1? No, because it has a 0. Now we do OR with 6. What do we get? 1, 1, 1. That is, for this, if we do OR with 6, we simply get 1, 1, and 1. Now 7, it contains all ones. So this can be the answer. So in this case, how many elements must be removed? If we consider this as the answer, 2 elements must be removed. Correct? And if we consider 1 as the answer, how many elements must be removed? 4 elements must be removed. Which is the best answer? Only 2 elements. So what are we doing simply? We are first sorting the array. Then we are doing OR element by element. And after doing OR, whatever result we get, we check if that is equal to 2 power x minus 1 or not. That is, if it contains only ones or not. If yes, then we can simply update our answer to removing the remaining elements. In the future, if we get a better answer, we update our answer. So in this case, 4 was the answer. In this case, nothing because r is not equals to 2 power x minus 1. In this case, r is equal to 2 power x minus 1. So we remove the remaining elements. 2 will be the answer. In future, if we get better answer, we'll update the answer with that. Now, how to directly get the answer? So if you are at 0, you got the answer as 4. N equals to 5. I value equals 0, that is index equals to 0. Can I simply say this is n minus I plus 1? You can check for this case as well. 5 minus 2 plus 1, which is 3, which is equals to 2. We got 2. So we can directly update the answer to n minus I plus 1 once we get our of 2 power x minus 1. So summing it up, first thing, we know 2 power x minus 1 will contain only ones. Second thing, we have to remove the minimum elements. Third thing, we have to sort the array. So what was the approach? First we sort the array, then do OR, and whatever OR value we get, we check if that is equal to 2 power x minus 1. How do we check? It should contain only ones. And if it is 2 power x minus 1, we update the answer to number of remaining elements. That is, we assume we'll remove all the elements. In the future, if we get better answer, then we'll update the answer with that better answer. Done. Shall we code it up? First, three test cases are given, NT, CNT, and we loop for t times. And then each time, first n is given, which is size of the array. We have read that. And we need to create an array of that size. After that, perfect. Simply read the input into the array. Now we have the input with us. What's the next step? Print the output. So, see out. Let us say array removal of we are passing array and the size of the array to it. And of course, output should be separated by new line. Yes, and array removal of array comma the size of the array. Now what are we supposed to do? We have to iterate on the array and simply have to do or. So end or answer, initial I'm keeping it as 0. So we need to start iterating for n I less than 0, I less than n, I plus plus. What we have to do? We have to do OR and check if the OR value equals to 2 power x minus 1 or not. If yes, we need to update the answer. So further, I will take the answer as well. Initially, what should be the answer? We'll assume all the elements must be removed, so that will be the answer. If we get a better answer, it will be updated. Yes, OR answer OR equals to shorthand notation array of n. Now what do we have to check? We got the OR value. We simply have to check if OR value equals to 2 power x minus 1 or not. So check OR answer. If this is the case, what do we do? Answer assigns n minus I plus 1. And at the message they return the answer. What's left of? Check function. Bool check. What we have to do now? Perfect. We have to check if it contains 0 or not. So while n greater than 0, if n and 1 equals to 0, we can simply return false. And every time we do a right shift. And if false was not written, then we simply return true. So this is how we check if the given integer in its binary representation contains 0 or not. So as long as it is not 0, we right shift, and every time the last bit we'll be checking. How to check the last bit? Simply do an and 1. If it is 1, we'll get as 1. If it is 0, we'll get as 0. That's it. Let us run and check. 2 and 2 are the expected outputs. Okay, we got 2 and 4. Any guesses why? Yes. If you have guessed it, we did not sort the array. We thought sorting it doesn't work. That's our discussion. Now we'll be getting 2 and 2. Perfect. Submit. Correct answer. So that was approach and the solution for the second question. Now let us solve the next question. Number 1. Given a positive integer x, find the smallest positive integer y satisfying all the conditions. What are the conditions? First condition, y should not be a prime. Second condition, y should not be a perfect square. And third condition, no factor of y should be less than x other than 1. So factors of y should be greater than or equals to x. It should not be less than x. And if there's any factor, it's only 1. We have to find such number. It's mentioned y might not fit in the 32-bit integer range. We'll come back to that later. And you are given t test cases. For each test case, you are given an integer x. We simply have to print that y. Output format. For each test case, we simply have to print the y separated by a new line. And again, it's mentioned y might not fit in the 32-bit integer range. We'll come back to that. Coming to the sample AO, we have 1, 2, and 3. For 1, the possible numbers that we can take are starting from 1, 1, 2, 3, and so on. So let us check. Can 1 be taken? First thing is 1 a prime? No. Are factors of y, that is factors of 1, greater than or equals to x, that is 1? Yes, 1 factors are 1 and 1, so they are greater than or equals to 1. But why can't we consider 1? Because 1 is a perfect square. What about 2? It is a prime. What about 3? Prime again. 4. Perfect square. 5. Prime again. 6. Let us check. 6. We have 1, 2, 3, and 6 itself. Do you see any factor of 6 less than 1? No. And is 6 a perfect square? No. Is 6 a prime? No, because it has more than 2 factors. So 6 is the answer. I got 6 as the answer. Coming to 2. Any number from 2 can be taken. 2 is a prime, excluded. 3 is a prime, excluded. 4 perfect square, excluded. 5, prime again. And 6, let us check. So for 6, these are the factors. Other than 1, do you see any factor lesser than 2? No. So for 2 as well, it will be 6. Coming to 3, can 6 be taken? 1, 2, 3, 4, 5 are rolled out already. We know why. And 6 cannot be taken because it has a factor which is lesser than 3. What about 7? It's a prime, so cannot be taken. What about 8? One of the factors of 8 is 2, so it cannot be taken. What about 9? Perfect square, so cannot be taken. What about 10? One of the factors is 2, which is lesser than 3, so cannot be taken. What about 11? Prime, so cannot be taken. What about 12? Again, factor is 2, so cannot be taken. What about 13? Prime, so cannot be taken. 14, factor is 2, so cannot be taken. 15, 15 is not a prime, not a perfect square. We simply have to check for the factors. 1 into 15 and 3 into 5. Other than 1, do you see any other factors lesser than 3? No. So for 3, 15 is the answer. So what would be a brute force solution? We simply start iterating from the given number and first check if it is prime. If yes, continue. If it is perfect square, then also continue. If factors of it, at least one factor of it, is lesser than the given number, then also continue. Else we simply return or print that number. But what will happen if you do exactly that? Here it's clearly saying that for 10 power 9, the numbers you'll start iterating from 10 power 9 and we go number by number. Worst case, it will take a it will be taking huge time and to get the factors also will be requiring so much time. And again storing those factors, so a lot of time. Of course, you can do it without storing the factors as well. You can simply check one by one factors. If it is lesser than the given number, you will simply neglect it. So, brute force, you might get a TLA. Any other way? I mean, can we optimize it somehow? Let us look. First, for any given number, how can we directly get the answer? Is there any way? It is a math question. Think in terms of that. So if you are given any number x and you have to find a number y such that factors of it are greater than x or equal as well. Which numbers can we pick? So we understood. After x, we need to take such number which is not a prime, not a perfect square, and factors of it must be greater than or equals to x. Now, if you are taking any number which is greater than x and not a prime, don't you think it will have a factor lesser than x? Of course it will have, right? If x is a prime, what is the first number you will be getting such that the factor of it will not be lesser than x? It will be x square. I mean, there are multiple numbers, but the first number that comes to our mind is x square. We can take this, but what's the issue? It's a perfect square. So that is ruled out. What else can we take? So first thing we have to find a number a such that factors of it should be greater than or equals to x. What kind of number is a according to this? So it should have a factor only greater than x. So can take a as prime? Then the factors of a will be 1 and a. But what's the issue? It's clearly said we cannot take a prime. Now let us take another number b which is also a prime. Factors of b will be 1 and b. These two numbers individually cannot be the answer. But what about the product of this? It can be the answer, right? A into b will be a number which is not having a factor lesser than x, and a into b is not a prime, and it's not a perfect square as well because a and b are different numbers. But what are a and b? Simply two primes which are nearest to x. Now can A be x as well? Yes, factors of A are 1 and A, factors of x are 1 and x. So if x itself is prime, then we can take x as well as A. But keep it in mind if it's only a prime. So how to get A and B? Simple. From x, we will start iterating until we get a prime. Let's say we get A. And from A, we start iterating, or to be more precise, from A plus 1, we start iterating until we get a prime and we get B. And we simply have to return the product of this. First, t test cases, so int t, c int t, and then while t minus minus, we are given an integer x. And what should we do? As we discussed, we have to find out a number, more specific, a prime number which is greater than or equals to x. So from x we should start iterating and get a prime. Once we get that a, we should also get b. What should we do for that? Perfect. From a plus 1 we should start iterating and then get the prime. Once we get a and b, what should we do? Simply print a into b. Separated by a new line. Do you see an issue with this? The given constraints x can be any value up to 10 power 9. So after reading x, you will get a value which can be equal to 10 power 9 as well. So get prime for 10 power 9 will be some number which is greater than 10 power 9, and get prime when we are calling it for b will be even more greater number, and the product of those will definitely not fit in the integer range. So that is why it's clearly given y might not fit in the 32-bit integer range. So what do we have to do? We can typecast or simply change these to long long. Now what's our task? Get prime function. So long line get prime or index. Now if you see here we're taking integer and we start adding. If the value goes to long, then what to do? Of course it will not go. It won't go. But if it goes, so you have to be careful. For this case, it will not go. So simply iterating from x would work. But if it goes, it will not work. So we will be taking long in that case. For this, even without taking it will work. Now, what do we have to do? We have to start iterating from x till where? We don't know till we find the prime. So is it correct to use for loop? Of course not. We'll be using while loop. So while the given number is not prime, what should we do? Simply increase the value of x until we get a prime. That's it. Are we missing something? Nothing as of now. Of course, return. Now the final thing, if we complete this is prime, How to check if the given number is prime or not? We simply have to check if it is having any factor from 2 to square root of its number. So from 2 to square root of its number, if there is a factor, that is if x mod I equals to 0, then we return false. Else we simply return true. That's it. Are I missing something here? Long index has been taken and we are checking square root I into I. So this should also be long. That's it. Let us test our code. Okay, so B was not declared in the scope. It's declared. What else? Long in B. Okay, we missed the semicolon over here. So we got 2, 6, and 15. But for 1, what should we get? 6. So what's missed here? 1 is not a prime. So if x equals to 1, what should we do? Return false. 6, 6, and 15. It worked. Perfect. Yeah, guys, that's it for this video. For more such videos, follow this channel and let me know which solution was more interesting in the comment section.